Hello dear students, welcome back to the video classes. This is the 11th lecture on the topic Determinants. In today's class, we are going to study how to find the minors and cofactors of a given square matrix or the determinant. In this session, we are going to study first definition of minors and cofactors, then their examples. Dear students, let me begin with the first definition called the minor, how to define the minor of a matrix. Now the definition goes like this: minor of an element matrix A, which is equal to Aij of order n cross n, is Aij, which is obtained by deleting its ith row and jth column, in which the element Aij lies, and the minor of an element is denoted by the notation Mij. Let me define once again the definition of the minor of a matrix or the minor of an element. The minor of an element Aij of a determinant is the Aij determinant obtained by deleting its ith row and jth column, in which the element Aij lies in. The minor of an element is denoted by the notation capital M, suffix ig. Dear students, here is an important remark. You can remember, minor of an element of a determinant of order n, where n is greater than or equal to 2, is a determinant of order n minus 1. Suppose a matrix is containing of order 2 cross 2, then the minor of that determinant or the matrix is of order n minus 1. Let me start defining the cofactor or the cofactor of a matrix. Cofactor of an element Aij is denoted by the notation capital Aij. It is defined by capital Aij is equal to minus 1 to the power I plus j, minus 1 to the power I plus j into Mij, where Mij is the minor of the element Aij. Means, in brief, let me define this. If minor of each element of a matrix is multiplied by the minus 1 to the power I plus j, then it becomes the cofactors of an element Aij. With the help of these two definitions, we are going to solve the few examples. Let me begin with the first question. Find the minors and cofactors of the elements of the determinant. Instead of a matrix, we have been provided the determinant containing 1, minus 2, 4, 3. We have to find the minor of each element of a given determinant. As per the definition of a minor, the minor of element 1 is given by the deleting that row and column consisting 1. We are left with 3. Therefore, the minor of 1 is 3. Likewise, the minor of minus 2 is, as per the definition of a minor, we can find out deleting the row and column consisting minus 2. We are remain with 4. Therefore, the minor of minus 2 is 4. Similarly, we can find the minor of 4. That 4 is in the second row and first column. Deleting the respective row and column, then the element which are left is called the minor of 4 is minus 2. Finally, the minor of 3. The minor of 3 is the deleting the row and column consisting 3. We are left with the number 1. Therefore, this value 1 is called the minor of 3. My dear students, you can observe here the given determinant is of order 2 cross 2. We have the element, that is minor of an element is of order 1 cross 1. The same problem let me explain in the next slide. Solution for the first question. The given determinant is containing the elements 1, minus 2, 4, 3. Therefore, the minor of each element is given as follows. The minor of an element 1, which is denoted by the notation capital M11. The suffix 11 indicates the first row, first column. Therefore, the deleting the row and column consisting 1, the minor of 1 is 3. Similarly, the minor of minus 2 is equal to that element minus 2 lies in the first row, second column. Therefore, it is denoted by the notation M12. Deleting the row and column consisting minus 2, the minor of minus 2 is 4. Likewise, dear students, we can obtain the minor of the second row. The minor of 4, which lies in the second row, first column. Deleting the row and column consisting 4, the minor of 4 is minus 2. Likewise, the minor of the last element of the same determinant, the minor of 3 is, it lies in the second row, second column. Deleting the row and column consisting 3, we are left out 1. Therefore, the minor of 3 is 1. Now, the same elements we can write in the matrix form or we can write in a determinant form. Therefore, determinant, the minor of 1 is 3, the minor of minus 2 is 4, the minor of 4 is minus 2, and the minor of 3 is 1. This is the minor of each element of a given determinant or the matrix. My dear students, we have the second example of the similar type. In this case also we have to find the minor of each element of a given determinant. Now let me begin with the minor of the first element of the first row. The minor of 2 is denoted by the notation M11. Deleting the row and column consisting 2, we are left with the first order determinant. The given determinant is of second order. The minor of that respective element will be of first order. Of 2 is 3. Likewise, the minor of minus 4 will be deleting the row and column consisting minus 4. Therefore, the minor of minus 4 is nothing but M12, which is nothing but 0. Likewise, the minor of 0 is minus 4. The minor of 3 is 2. Therefore, here we have a determinant containing the minors of each element of the first row and second row are respectively 3. This is the minor of 2, minor of minus 4, the minor of 0 is minus 4, and the minor of 3 is 2. Or you can write in the form of a matrix. Now these are the examples of second order. Dear students, with the same examples, let me find out how to get the cofactors of a given determinant or a matrix. Dear students, if you know the minors of each element of a given determinant, then it will be easy to find the cofactors of the same elements. In earlier video, dear students, we have observed that the sign conventions for the second ordered is plus, minus, minus, plus. And for third order, we have the sign conventions plus, minus, plus, minus, plus, minus, and plus, minus, plus. With the help of these sign conventions, we are able to write the cofactors of each element of a given determinant or a matrix. Now let me begin with the first example. Cofactor of an element 1 is denoted by, the cofactors are denoted by the notation capital A or capital C. Therefore it is A11. 11 stands for the first row, first element, which is nothing but 1. The cofactor of 1 is, actually the minor of 1 is 3. If that 3 is multiplied with a plus sign, then we'll get a cofactor of 1 is plus 3. Now the cofactor of minus 2, first I'll find the minor of minus 2. Minor of minus 2 is plus 4. But if that is multiplied with a negative sign, therefore minus of plus 4 is minus 4. Therefore minus 4 is the cofactor of minus 2. Similarly, the cofactor of 4, it lies in the second row, first column. The minor of 4 is minus 2 and that is multiplied with a minus sign. Therefore minus of minus 2 is plus 2. Therefore plus 2 is the cofactor of 4. Finally, we have the cofactor of 3. Let me find out. The minor of 3 is 1 and it is multiplied with a plus sign. Therefore it becomes a cofactor. Therefore the cofactor of 3 is plus 1. Now if these minors are multiplied with plus, minus and minus plus sign, then those becomes the cofactors. Therefore the cofactor of this determinant is nothing but the first row cofactors are 3, minus 4, then plus 2 and plus 1. These are the cofactors. If the minors are multiplied by plus, minus, minus, plus for second order, then those becomes the cofactors of a given determinant. Dear students, with the help of these examples, let me start the one more problem so that it will be easy to find the cofactors of this given determinant. Let me begin with cofactor of the element 2. Dear students, let me get the cofactor of 2. The minor of 2 is 3 and if it is multiplied by plus sign, it is plus 3 is the cofactor of the first element. Similarly, the cofactor of minus 4, I'll find out the minor of minus 4. Minor of minus 4 is 0 and if it is multiplied by minus sign, it becomes a cofactor. Therefore, the cofactor of minus 4 is 0. Similarly, the cofactor of 0, it lies in the second row, first column. Therefore, the minor of 0 is minus 4 and minus 4 is multiplied by minus. Minus 4 is the minor and if that is multiplied with a minus sign, it becomes a plus 4. Therefore, the plus 4 is the cofactor of 0. Finally, we can find the cofactor of 3. Before I find the cofactor of 3, let me find minor of 3 is 2. And this 2 is multiplied by plus sign, then it becomes again a plus 2. That is nothing but the cofactor of 3 is plus 2. Therefore, in this case, the cofactors of each and every element is 3, 0 and 4, 2. Dear students, now let me take the third order determinant. Find the cofactors, minors and cofactors of each element of the given determinant. My dear students, in this case, the given matrix or the determinant is of third order. Now let me find out the minor of each and every element. Now in this case, the minor of 1, that is the first element, deleting the respective row and column consisting 1. Then we have the second order determinant. By solving the second order determinant, we get, that is 5 2s are 10 and 1 minus 1s are minus 1, minus of minus 1 is plus 1. Therefore, the cofactor of 1 is 11. We can find the minor of the second element, that is 0. Deleting the respective row and column, we are left with the second order determinant. Therefore, the minor of 0 is 6. Likewise, the minor of 4, we can find the minor of 4, deleting the first row and first column. And if I expand this, 3 1s are 3, minus 0 5s are 0. Therefore, 3 minus 0 is 3. Therefore, 11, 6 and 3, these are the minors of the first row. Similarly, my dear students, we can find out the minors of the second row and third row respectively. The minor of the second row are, it is minus 4, 2 and 1. Similarly, the minor of the third row are 20, 30 and 5. Therefore, the minor of the given matrix or the determinant are, it is a determinant or we can say matrix containing 11 is the minor of the first one, 6, then 3. Second row elements are minus 4, 2 and 1. The last row elements are 20 and minus 13 and last element of this determinant is 5. These are the minors of each and every element of a given matrix. Dear students, we have the one more example of the third order. We should find the minor of each element of a given determinant. Minor of minor of 1, deleting the row and column consisting 1. 1 ones are 1, minus 0, will get 1. Similarly, the minor of 0, that is lies in the first row, second column. 0 ones are 0, minus 0, that gives 0. Similarly, we can find the minor of the last element of the same row, deleting that row and column consisting 0. 0 ones are 0, 0 are 0, minus 0, that gives again 0. Therefore, the first row minors are 1, 0, 0. Second row minors are 0, 1, 0, and the third row minors are 0, 0, 1. Therefore, we have the determinant containing the elements 1, 0, 0. Second row elements are 0, then again 1 and 0, next 0, 0 and 1. These are the minors of the given determinant of order 3 cross 3. Dear students, we can find the cofactors of the given determinant. Now, to find the cofactors, we should multiply the sign conventions to the respective elements of the first row, second row and third row. Therefore, here it goes like this. The minor of the first element is deleting the respective row and column, that is 10 plus 1, and that 10 plus 1 is multiplied by plus sign, that gives 11. Therefore, the cofactor of 1 is 11. Similarly, the cofactor of 0, that is the second row, deleting the row and column consisting 0. 3 2s are 6, 0 minus 1s are 0, that is 6 plus 0, and its sign convention is minus sign, therefore minus 6. Minus 6 is the cofactor of the second element. 6 is the minor of the 0, but if that 6 is multiplied with a minus sign, it will be minus 6. It is a cofactor of that second element of the first row. Therefore, let me find out the minor of 4. Minor of 4 is 3 ones are 3, minus 0 5s are 0. That is 3 is minus 0 is 3, and that which is multiplied with a what it is? Plus sign. Therefore, plus 3. Therefore, 11 minus 6 and plus 3. These are the cofactors of the first row. Similarly, we can find the cofactors of the second row. Second row elements are 4, 2, plus 1. Minus, plus, minus. These are multiplied with the minus. Those becomes a cofactors. The cofactors of the third row are plus, minus and plus sign is multiplied to the minus of the respective elements 0, 1 and 2, that gives 20, 13 and 15. Therefore, the cofactor matrix is written as, or the cofactor determinant is written as determinant. The first row elements are 11, minus 6 and 3. Second row cofactors are, it is 4, 2 and minus 1. 4, 2 and minus 1. The last row elements are, it is 20, 30 and 5. These are the cofactors of the given determinant. 4, 2, minus 1. This one is minus 1. In the same way, we can find the cofactors of the second example. Now, it is containing 1, 0, 0, 0, 1, 0, 0, 0, 1. The cofactors of all these elements are 1, 0, 0. Then second row elements cofactors are 0, 1, 0, which are multiplied by the first plus, minus, plus, minus, plus, minus, plus, minus, and again plus. These are the cofactors of every determinant. With this, I conclude my today's lecture. If you have any queries, please contact the given below number. Dear students, in the next week there is an exam, that is the first unit test for PUC second year. It will start from 15th, 16th and 17th. In these 3 days the exams are conducted. The syllabus for the first unit test is matrices and determinant. Determinant is up to the area of a triangle, finding the area of a triangle by using determinants. Now hereafter, whatever the videos are uploaded for the next week, those are not there for unit test. Thank you. Stay home, stay safe.